All right, future network gurus, listen up. Exam time is right around the corner. Welcome to a super fast review session designed to do just one thing: help you totally crush the OSI model and ace that networking exam. So let's just jump right in, shall we?
Have you ever really stopped to think about what happens when you click on a link? I mean, it feels like magic, right? How on earth does your computer send a request to a server that could be halfway around the world and get a whole web page back all in a blink of an eye? Well, it's not magic. It's a very organized, 7-step journey, and we're about to follow a piece of your data on that exact trip.
So here's our game plan for this study session. We're going to start with the big picture of the OSI model, then we'll break down every single layer from top to bottom. We'll be focusing on the stuff that is absolutely going to be on your test. This is your high-speed study guide.
Okay, first things first, the big one, the OSI model. You gotta understand this because, honestly, it's the foundation for pretty much everything else in networking. Let's make sure we nail this.
So what even is a network model? Think of it like a blueprint. It takes this ridiculously complex job of sending data across the world and chops it up into smaller, much more manageable steps. These steps are called layers, and this whole assembly line idea, it's genius because it creates a universal language that everyone can use to build and fix networks.
And here they are, the 7 layers of the OSI model. A great little trick to remember these for your exam is a mnemonic like, "Please do not throw sausage pizza away." Super cheesy, but it works. So when you send data, it travels down this list, from layer 7 all the way to layer 1. And on the other end, when the data is received, it goes right back up. Let's start at the very top.
Okay, let's talk about the upper layers. That's application, presentation, and session. These 3 are like the front office of our data's journey. They work super closely together to get the data from your software ready for the trip. The application layer talks to your program, the presentation layer is like a universal translator, and the session layer basically manages the conversation. So layer 7, the application layer. This is the one we interact with the most. Now, here's a really common mistake people make, so listen close. This layer is not your web browser or your email app. No, instead, it's the behind-the-scenes service that those apps use to talk to the network. Just below it, you've got layer 6, the presentation layer, which handles stuff like encryption and making sure the data is in the right format. And layer 5, the session layer, is what opens, closes, and manages the connection between 2 computers. And here are the rock stars of layer 7, the protocols you absolutely positively have to know. When you're surfing the web, your browser is using HTTP. When you send an email, that's SMTP doing the work. And DNS? DNS is basically the internet's phone book. It translates a simple name you can remember, like google.com, into an IP address that the network actually understands. All right, moving on down to layer 4, the transport layer. You're going to want to pay extra close attention here because the whole TCP versus UDP thing, that's a classic exam question. This layer is all about the nitty-gritty logistics of getting your data delivered. You know, this is the perfect way to think about it. The transport layer takes that big chunk of data from the top layers and does something called segmentation. It chops it up into smaller, more manageable pieces called segments. Then it has to decide how to ship them. Is it going to be a premium service with tracking or just standard, fast mail?
And that brings us to our 2 big shipping options, TCP and UDP. TCP is like your super reliable courier service. It's connection-oriented, which means it sets up a connection, checks to make sure every single piece arrives in the right order, and if anything gets lost, it asks for it to be sent again. UDP, on the other hand, is the fire and forget method. It's way faster because it's connectionless. It doesn't bother with all that checking, but there are no guarantees.
So how do you choose? Well, for something like web browsing or sending an email, you need every last bit to be perfect. Accuracy is everything, so you use TCP. But what about streaming a video or playing an online game? You can probably handle a single dropped pixel or a tiny glitch. What you can't handle is lag. That's why they use the much faster UDP. Speed is way more important than absolute perfection. Okay, so our data's been chopped up and given a shipping method. Now we hit layer 3, the network layer. This is like the GPS for the internet. Its main job is to figure out the absolute best path for your data to get from your computer to its final destination, even if it has to cross dozens of different networks.
The main job here, the key word you need to remember, is routing. This layer takes the segments from the transport layer and wraps them up into what we call packets. It adds a new header with the source and destination addresses. And the hero of this layer is the router. The router reads these addresses and makes smart choices to forward the packet along the best possible path.
So how does the router know where to send anything? With an IP address. It's just like a postal address you'd write on a letter. Every single device connected to the internet has its own unique IP address, and that's what lets data find its way directly to your machine from anywhere on the planet. Now, you're going to see two main types of IP addresses. IPv4 has been the workhorse for decades, but here's the crazy part. With billions of devices online, we are literally running out of IPv4 addresses. That's why IPv6 was created. It uses a much longer 128-bit address, which gives us, well, a nearly infinite supply of addresses for all the devices of the future.
Okay, we've successfully routed our data across the vast internet. The packet is now getting really close to its final destination network. So it's time to hand things off to the lower layers, which are going to handle that last little bit of the journey inside the local network.
Next up is Layer 2, the data link layer. This layer is all about communication within the local network. It takes that IP packet from Layer 3 and wraps it up again, this time into something called a frame. This frame has a physical MAC address. Here's a great way to think about it. The IP address is like the street address of an apartment building, but the MAC address is the specific apartment number inside. The key device here is a network switch. And this layer also does some important error checking.
And finally, we've reached the very bottom. Layer 1, the physical layer. This is where things get real. Literally. This layer takes the frames from Layer 2 and turns them into raw bits, just ones and zeros. Then it sends those bits out as physical signals, electrical pulses down an Ethernet cable, radio waves through the air for Wi-Fi, or pulses of light through a fiber optic cable. It has no idea what's in the package. Its only job is to move the bits.
And that's the whole journey down the stack. Whew! Now, for the most important part of this whole review, let's put it all together so it really sticks in your head for the exam.
This whole process of adding a new wrapper or header at each layer, that's called encapsulation. For your exam, you'll want to remember the names for the data at each stage. So you start with data, which becomes a segment at Layer 4, then a packet at Layer 3, then a frame at Layer 2, and finally, just bits on the wire at Layer 1. Each step wraps the one before it, like a set of Russian nesting dolls.
Now, once the data gets where it's going, the exact same thing happens, but in reverse. And that's called, you guessed it, de-encapsulation. The receiving computer's physical layer grabs the bits and turns them back into a frame. The data link layer checks the MAC address, unwraps the frame, and passes the packet up. The network layer checks the IP address, unwraps the packet, and so on, all the way back up until the original data pops out at the right application. So, after all that, what's the big takeaway here? The single most crucial point? The OSI model isn't just some boring theory, it is the essential roadmap, the universal blueprint that lets a Mac talk to a Windows PC, an iPhone talk to an Android server, and makes all of modern communication possible. It's literally what makes the internet work.
You did it. You just walked through the entire journey of a single piece of data across the network. You get the logic, you get the layers, you get the protocols, you now have the blueprint. So walk into that exam feeling confident. You are ready for this. You got this.